Intro to decimals. In this video we will talk about decimals, place value, and arithmetic with decimals. So let me say at the outset, if this is something relatively easy for you, if you're very comfortable already with adding, subtracting, multiplying, dividing decimals, then you probably don't need to watch this video. You might just want to skip through briefly to make sure that everything is reviewed. But don't spend time watching this whole video if you already know this inside out. This video is designed for people who are a little shaky with decimals and want a thorough review of the topic. So let's begin. First, think about positive integers, just ordinary positive integers. If we have the number 256, what that means is we have 2 hundreds, 5 tens, and 6 ones. Those are the place values. So we could write this number in the form 256 equals 2 times 100 plus 5 times 10 plus 6 times 1. That's expanding it in terms of its place values. Notice that as we move a digit to the left, the place value is multiplied by 10, and as we move a digit to the right, the place value is divided by 10. So for example, look at that 8 in the middle. That 8 is in the thousandth place. If we move to the left one step to the 7 is in the 10,000th place. So when we move from the 8 to the 7, the place value gets multiplied by 10. Similarly, if we move to the right, from the 8 to the 3, the 8 is in the thousandth place, the 3 is in the hundredth place, and so the place value gets divided by 10. Decimals simply extend this same pattern to the right of the decimal point. For example, the number 39.0625, what does that mean? Well, first of all, the 3 is in the tens place. We have a 9 in the ones place. The 0 is in the tenths place. The 6 is in the hundredths place. The 2 is in the thousandth place. And the 5 is in the 10,000th place. We could write this number as follows. We could write it as 3 times 10 plus 9 times 1 plus 0 times 1/10 plus 6 times 100th plus 2 times 1,000th plus 5 times 1/10,000th. So this is the expanded form in terms of place value. The decimal places to the right of the decimal point represent negative powers of 10. So 0.1 is 1/10, that's 10 to the negative 1. 0.01 is 100th, 10 to the negative 2. 0.001 is 10 to the negative 3. 0.0001 is 10 to the negative 4, and so forth. You could extend this pattern. What can be a little confusing about this? There are a few things that are a little confusing. First of all, notice the 0 to the left of the decimal point. That's purely decorative. I put that in for clarity. That has no mathematical meaning. All that matters here are the numbers to the right of the decimal point. Now, some people get confused because how many zeros should these things have? Well, if we look at 100, for example, 100, 10 to the positive 2, that's 1 followed by 2 zeros. That's very clear. People recognize 100. So then when we go to 100th, notice that that's something that only has 1 zero. It's 0.01. It only has 1 zero, and that really confuses people. But notice that 0.01, that's 2 decimal places. And this is very important. If we look at a positive power of 10 and count the number of zeros, that number of zeros will be the same as the number of decimal places in the corresponding negative power of 10. So again, say the number 10,000. The number 10,000 has 4 zeros. Well, the number 1/10,000th, 10 to the negative 4, that has 4 decimal places, 4 places to the right of the decimal point. Also notice that the additional zeros to the right of any non-zero digits are meaningless. They make absolutely no difference. So for example, if I write 3.75, if I tack on extra zeros to the right, those are completely meaningless. They mean absolutely nothing. Now you may have this dim memory from science class that there was something called significant figures, and sometimes these zeros mattered and sometimes they didn't. We're not going to worry about that. Significant figures are not on the test. The way that they use numbers in science is not the way that they're used on the test. So on the test, these zeros are completely meaningless. Now we can take a look at arithmetic with decimals. Adding and subtracting decimals is quite straightforward. We simply line up the decimal points and add or subtract vertically. So suppose we have to add these two decimals. We're going to line them up vertically. So the decimal places are lined up. Once they're lined up, then we just add. Similarly, if we have to subtract these two numbers, we're going to line them up. The decimal places are lined up together. Now that they're lined up, we're simply going to subtract. And that's all there is to adding and subtracting decimals. For multiplication, step 1 is to count the number of digits to the right of the decimal point. So suppose we're going to multiply these two numbers. For each one, we have to count the number of digits. The first factor has 2 decimal places, and the second one has 3 decimal places. Now we add those. 2 plus 3 is 5. The product will have 5 decimal places. So now we know how many decimal places the product will have, even before we do the multiplication. Now we're just going to ignore the decimal points entirely and find the product as if they were 2 positive integers. So suppose we just had the 2 positive integers, 625 times 48. What is this product? Well, how do we find this without a calculator? Turns out there's an amazing trick that we'll talk about in a later video. This is called the doubling and halving trick. Turns out when you're multiplying two numbers, of course, one thing that's always allowed, you could multiply one of them by 2 and divide the other by 2. That's one thing that's always allowed. It turns out that it's very advantageous to do this if one of the numbers is even and the other number is a multiple of 5. Turns out that it's very advantageous to do this. So what I'm going to do, I'm going to divide 48 by 2. That's going to become 24. I'm going to multiply 625 by 2. 625 times 2 is 1250. So I change this to 1250 times 24. That has a 50 in it, so I'm going to multiply that by 2 again. So divide 24 by 2, I get 12. Double 1250, I get 2500. Well, that also has a 500 in it, so it makes sense to do this again. I'm going to double 2500 and halve 12. Half of 12 is 6, and 2500 doubled is 5000. Well, now I've got it into a form where it's very easy to multiply in my head. 5000 times 6, that's 30,000. So this is a very handy trick to keep in mind. Now we know we need 5 decimal places. We found that out from the original problem. So we put the 5 rightmost decimals of this product to the right of the decimal. And notice that this product only has 5 decimal places. It only has 5 places, so all of them are going to get put to the right of the decimal point. So when we multiply 6.25 times 0.048, we get point, and then we write 3, and then all the zeros. Well, of course, all the zeros don't matter. We can just write this as 0.3, 3/10. Notice that to find a power, that's a special case of multiplying. So, for example, suppose we have to do 0.03, this is 3/100 cubed. How do we do this? Well, of course, this is 0.03 times 0.03 times 0.03. Notice what we have here, that's 2 plus 2 plus 2, 6 decimal places. The product will have 6 places to the right of the decimal point. So we know that even before we multiply. Now just consider the number itself. 3 cubed is 27, so that last 7 must land 6 places to the right of the decimal point. It must land in the 1/1,000,000th place. So 0.03 cubed is 0.00027. That 7 is 6 places to the right of the decimal point, and this is 27 millionths. Now division of decimals. To start, simply move the decimals of both numbers 1 place to the right and continue until the denominator, the divisor, is a whole number. When we move a decimal 1 place to the right, say 2.45 to 24.5, we are multiplying the number by 10. Since we multiply both the numerator and the denominator by 10, the value of the quotient remains unchanged. Essentially what we're doing is we're multiplying by 10 over 10, which is 1. So for example, suppose we start with this. Well, we can start sliding that decimal point to the right. Slide it to the right once, slide it to the right again. At this point, the numerator is now an integer, but it's really the denominator that matters, so we have to keep sliding to the right. What this does is adds zeros at the end of the number in the numerator, and finally we get that number in the denominator down to an integer. Now we have 5,600 divided by 7. Well, that's easy to do. That's just 800. So now, let's look at another example. Suppose we're dividing these two decimals. Again, start sliding to the right. Slide them to the right 1 point. Well, now notice we could keep on sliding to the right, but notice 0.25, that's a quarter. So notice that a very easy way to cancel that would just be to multiply the numerator and the denominator by 4. And if we multiply by 4, in the denominator, a quarter times 4, that's just 1, so we multiply the numerator by 4, and of course we get something over 1, so it just equals 0.0052. So 52 10,000ths. In summary, we talked about place values in decimals, and we talked about how to add and subtract, multiply, and divide decimal numbers.